The final part of National 5 Maths Surds topic is rationalising the denominator. And rationalising the denominator of a fraction means that you're writing the fraction without a surd in the denominator. So for rationalising a simple denominator is one that has a term of the form something like root 6. It could be root 2, root 5, but any simple surd. Our method for rationalising is we're going to multiply the top and the bottom of the fraction by the surd in the bottom. So imagine that you're making equivalent fractions. If we were making a half into something out of 12, we would multiply the top and the bottom by 6. So we're not actually changing the value, we're just scaling it by that surd. Once we've multiplied the top and the bottom of the fraction by the surd, we're going to simplify fully any surds that are on the numerator, and then we're going to simplify fully any fractions so that it's in its simplest form. So the first question we've got is to rationalise and simplify fully 1 over root 3. So the simple surd on the bottom is root 3. So the first thing we're going to do is we're going to multiply the numerator and the denominator by root 3 over root 3, which is equivalent to 1. So 1 times root 3 gives us root 3, and root 3 times root 3 gives us 3. Now the long way of doing that would be root 3 times 3 is 9, and the root 9 is 3. Basically, if you were multiplying a surd by itself, you are going to end up with the number underneath the surd. So our final answer is going to be root 3 over 3. Now, what if you've got a coefficient of your surd? Now, if you want to, you could multiply by 2 root 10 and 2 root 10 for your numerator and your denominator, but you don't need to multiply by the 2. We're only multiplying by that surd. So we're going to multiply the numerator and the denominator by root 10. If you multiply by 2 root 10, it means that you're going to have a lot more simplifying to do at the end. So we're going to end up with 5 root 10 over, and it's going to be 2 multiplied by 10, which gives us 5 root 10 over 20. Now root 10 is in its simplest form because it has no perfect square factors, because the factors of 10 are 1, 2, 5 and 10, and none of them are perfect squares. However, we can simplify that fraction because 5 and 20 have a common factor of 5. So 5 goes into 5 once, and 5 goes into 20 4 times. And so our final answer is going to be root 10 over 4. Now, the next example, there are 2 ways of approaching this. The first way is to multiply the top and the bottom by root 72. The second way is to simplify root 72 first, because that might make our multiplication easier at the end. So I'm going to take this root 72 over to one side. Now, the highest perfect square factor of 72 is 36. So I'm going to rewrite that as root 36 times 2. And that gives me root 36 root 2, which gives me 6 root 2. And I'm now going to substitute that back in over to my original question, which was 4 over root 72. So I'm going to have 4 over 6 root 2. And while I'm here, I'm going to simplify that fraction because they're both on my 2 times table, so that is 2/3. Now I want to multiply by my simple surd, so I'm going to multiply the top by root 2 and the bottom by root 2. So I'm going to have 2 root 2 on the top, and I'm going to have 3 times 2 on the bottom. I can cancel those 2's, and so my final answer is going to be root 2 over 3. My final example is looking at working with brackets again. I've got 2 root 3 take away 1 divided by 2 root 6. Now remember that 2 root 3 take away 1 is in a bracket, because that divide by a line means that there's brackets around the top and there's brackets around the bottom. So I'm going to multiply by root 6 over root 6. So I'm going to get root 6 brackets 2 root 3 take away 1 all divided by 2 times 6. So now I need to expand my bracket using rule 1. So root 6 times 2 root 3 gives me 2 root 6 times 3. Take away root 6 times 1 is root 6. And then 2 times 6 give me 12 on my denominator. So I end up with 2 root 18 take away root 6 divided by 12. Now I need to check that whether or not I can simplify any of my surds, and I can simplify root 18 further. So if I come up here, I've got 2, and my root 18 has a perfect square factor of 9. So I'm going to write that as 9 times 2, take away root 6, all divided by 12. So my next step is to say 2, and that's root 9, root 2, take away root 6, all divided by 12. Now I need to replace my root 9 with 3 root 2, take away root 6, all divided by 12. And 2 times 3 gives me 6 root 2, take away root 6, divided by 12. Now I can't simplify that any further unless I split it into 2 separate fractions. So I could, and it's not necessary to do so, separate that into 6 root 2 over 12, take away root 6 over 12, which will allow me to simplify that fraction, because 6 and 12 are both on the 6 times table, giving me a final answer of root 2 over 2, take away root 6 over 12. But as I said, 6 root 2 take away root 6 divided by 12 is a perfectly valid answer for simplifying fully.